Hello and welcome to a new In the Mail. Usually when I order stuff from China, I mean the mainland, it takes about 3 or 4 weeks for it to arrive to Romania, and the stuff that comes from Hong Kong takes about 5 to 6 weeks to arrive to Romania. But during the holidays period, like starting with orders placed from half of November up to 31st of December, it's really taking a very long time for them to arrive, something like 8 or 9 weeks, and sometimes there is also a very good chance the package will never arrive and will get lost in transit somehow. So right now about a third of the items I've ordered in the past 2 months are missing, and there's a very good chance they will never arrive. But anyway, I also have a bunch of items that have arrived, so let's get started looking at them. So our first item is this USB GPS module, and I got this one for about $8 from banggood.com. The reason I got it is, well, I don't plan on using it for its intended purpose as an USB GPS. I would have no use for something like that. Instead, I noticed this marking on the case which said Ublox 7, and I thought there must be a Ublox 7 GPS GLONASS module for less than 10 bucks. Normally you would find Ublox 7 Breakout modules for about $12, and I said to myself there must be some test pads inside with the UART interface pins that I could use and repurpose this module. And just to see if that's true, I'm going to open this little module and check for that. And unfortunately, as we can see, there are no test pads on this small module. I can see the two USB signals coming from the chip and going to the actual USB connector, but I don't see any test pads for the UART signals. And I know I have checked the datasheet for the Ublox 7 chip, and the UART pins are somewhere in this corner, and I don't see any vias or traces coming from those pins. This is actually a QFN package, and I guess with a lot of care and hard work under magnifying glass, I could probably solder a couple of very thin wires directly to the QFN pads, but that's going to be difficult, and it won't be a very reliable solution. Anyway, if I decide to do that, I will shoot a video and upload it on my channel. Next, I got these tiny 0.36 inch 4-digit 7-segment LED displays. I got these because I have this older and very crappy quality Chinese power supply that I would like to mod and upgrade. Basically, I would like to fit this linear power supply board that I assembled in another video together with a toroidal transformer, and for the front panel I would like to build my own voltmeter and ammeter using these 7-segment displays. It should give me quite usable and good power supply in the end, but I just need some time to design and build the project. These are red LEDs. I tried to get them in a white version, but I couldn't find any on stock for this on this size, 0.36 inch with 4 digits. So I stuck with the red LEDs. The next item is a 7-segment driver IC, and you can probably see the connection with the previous item. There are multiple choices out there when it comes to driving 7-segment displays, and depending on the application and budget you have plenty of choices. I decided to go with this particular IC, the TM1638, because I saw it was present in the majority of 7-segment LED modules sold on eBay. Also, it was quite cheap at $1.57 for 2 pieces, and it is also quite a versatile chip. For example, with just one of these, I can drive up to 10 digits 8-segment displays. In my case, I will be driving 8 digits in total, 4 for the voltage display and 4 for the current display, and the 8 segment is the dot present on my modules for each digit. Reading from its datasheet, I learned the chip can also read the keypad matrix and it has brightness level control. For communication, the chip implements a simple serial interface, and there should be readily available Arduino libraries for talking to this chip. Of course, there are alternatives from the reputable manufacturers like TI, Maxim and others, but those are more expensive and I don't think it's worth buying those for such one-off hobby projects while there are cheaper alternatives on the market. This one is a 12-volt solenoid electric lock, and too bad it doesn't also come shipped with the matching metal plate. But I guess you can find the matching metal plate quite easily. This is the type of electric lock that might be used for a small cabinet door or for a small drawer. This of course won't provide you with much security, but you can kind of see that judging by its size. Let me just show you how it works. I have here 12 volts DC from my bench power supply going through these resistor leads to the JST connector of the solenoid. And if I energize it, it will actually retract the locking mechanism momentarily. Oh, I had a bit of contact bounce. But you can see I need to keep the power applied if I want the locking mechanism to stay retracted. So this means it's not a latching system. You'll have to keep the coil energized for the lock to remain open. And the current draw for this thing, I'm looking at my power supply right now, and it's about 0.46 amps. So that means about 5.5 watts, just something to consider if you're implementing this in a design. This one came from eBay for about $4 free shipping, and as usual the link is in the description below. Next item is an Arduino Mega 2560 clone. And let me just open the anti-static bag and see how this Arduino clone looks like. This one has the SH1106 serial to USB converter, which is an okay solution. I haven't had any problems so far with these USB to serial converters. I don't know if there is anything else different from a standard original Arduino Mega, because I'm not that much into Arduino, but it sure was a cheap thing to get at $8.45 with free shipping. The build quality looks reasonable. This looks like a good FR4 PCB, and instead of using a fake FTDI chip like they used to, or the Mega chip for USB to serial conversion, which would make it more expensive, they went for the CH340G, the cheaper alternative, and I don't think there is anything wrong with that. I definitely think it's good enough for hobby projects, and I have confidence it will do its job just fine. So link for this board is in the description below. Next up I have this small module, which also came in an anti-static shielding bag. Let me just zoom in a little bit closer. This one is a very basic and simple RS232 to TTL converter module using the Max 232 converter IC or some clone, which I don't mind in this case because it's such a simple and basic module, but just something to consider there is always a possibility that when you get these modules from China that they might contain a clone of the original IC. I recently needed one, and I had to hack an old board. It was messy. It would have been much easier if I would have had one of these modules so that I can just connect a couple of wires and get the job done. In fact, this module was advertised as a Max 3232, which is actually the 3.3 volt version of the chip, making it compatible with the 3.3 volt logic level, which is basically everywhere these days. There are different versions of these modules, so depending on where you order them, they might look a bit different, but they will do the same job. And if we take a closer look at the markings on the chip, we see it is indeed Max 3232, which is actually the 3.3 volt version. These are some 53mm Alligator clips. They're a bit more expensive than the usual Alligator clips that you find on eBay, but they do seem to be better built, and they look like they can handle quite a bit more current and voltage as well. At first I thought I will use these and solder some thick silicone wires, making myself some very nice bench leads, but then when I got them I noticed they have the 4mm banana receptacles at the back, so I can use these with my existing cables that have 4mm banana jacks. Just like that, you can connect them with your existing wires and use them like that. Quite nice, I like these, and the link for them as usual is in the description below. This is a 10 pack of test hook clips. Probably not very good quality ones, but for their price they are usable and easier to find. If you remember in the previous In the Mail episode, and there should be a link appearing right now on the screen, I got some silicone wires, different gauges, and I believe I mentioned I plan on making myself some bench cables. For example, I have these older ones that I constantly keep connected to my bench power supply, so they have 4mm banana plugs on the other end and the hook clips on this end, and I constantly keep them connected to my linear bench power supply, so whenever I need to power something it's as simple as pushing the on-off button on the power supply and connecting these clips. If you have the time, I recommend making your own good quality cables, different colors, different gauges. Don't buy the cheap ones from eBay because they are quite crappy, and it will give you a lot of intermittent connection problems. In here I have a set of 5 pieces, 20 by 20 by 15mm small extruded heat sinks. These are quite cheap and you can use them for anything where you need cooling and they would fit. I actually needed one of these for a mini ITX motherboard, which is supposed to be passively cooled on the CPU and overall, but on one of the chipsets present on the PCB it doesn't even have a small heatsink on, and I measured the temperature of that chip and it was 90 to 100 degrees or something like that if I remember. So I decided to just get one of these and glue it on top of the chip to keep it a bit cooler. But as I mentioned earlier, you can use them for anything where you can fit them. I guess you could also probably use them to keep your Raspberry Pi cool if the size would fit on the board and it doesn't hit anything close to the CPU. And they come with these presumably thermal adhesive tape. This is one of the most popular Bluetooth modules out there, and partly because of the format and the numerous breakout boards available, and partly because it is so inexpensive and such a small module. As you can see, I have placed my ESD safe spudger next to it so you can get a feel for its size. I tend to use these modules for basically any project where I want a serial link with a computer or smartphone and I want it to be wirelessly or isolated, because you can easily create a Bluetooth virtual serial port and quite easily have an isolated serial COM with anything you're working on. I needed one particularly for the dark load project that I'm working on, which is an electronically controlled dummy load. I will mainly use it on the bench, but I also want to add remote control and logging capability, so this module will be soldered right here on the PCB, and we'll be talking to the microcontroller giving me virtual serial port. These are 10 pin 1mm pitch 150mm long flat cables, and these are the corresponding surface mount connectors with the same size and pitch. These are kind of universal. You use them for whatever your application is and you need a link between 2 points. In my case, these will also be used in my dark load project to link the front panel to the actual main PCB sitting behind the front panel, something like this. I didn't want to complicate things, so I went for the 1mm pitch because it's quite okay to solder and work with, but if you're constrained by space, you can find these in a variety of sizes and pin pitches. 150mm is a bit longer than what I actually needed, but I can live with it, or you can just cut the flat cable to the required length and strip a bit of the isolation from the end to ensure you get electrical contact between the cable and the connector. Just make sure you pay attention to the electrical contact orientation for the connectors. Some are bottom contact, some are top contact, and this means your flat cable has to go into that orientation because the flat cable will usually only have non-isolated pads on a single side. This is a 1.3 inch OLED display, 128 by 64 pixels resolution with an SH1106 controller. And if you've watched the previous episode, you saw the you saw the update I gave on the dark load project front panel that uses one of these OLED displays. And you can see the front panel right here. And I have the OLED display attached with some double-sided sticky tape and soldered on the PCB, and it gives a really nice looking front panel. I got these directly from Taobao, the Chinese eBay. They tend to be cheaper in there, and if you have something like an agent that forwards stuff to you, it's really easy and cheap to get them from that website. But you can also find them on eBay, though the 0.96 inch version is more popular and easier to find. For this 1.3 inch version, I believe you can find them in blue or white, and I especially like the white version, but unfortunately there must have been some kind of shortage because I tried like 5 different sellers that were selling these and none had the white version on stock. So either this or they all get their stuff from the same higher level supplier, and that supplier was out. Both the 0.96 inch and the 1.3 inch version have the same resolution of 128 by 64 pixels. It's just that the larger one you get slightly larger pixels. There are readily available Arduino libraries to drive these. They only require a few external capacitors, and they're supposed to be hot bars soldered to a PCB footprint, but you can do it with a regular soldering iron as well. I highly recommend you get a couple of these, either the 0.96 inch or the 1.3 inch version, and give them a try. I'm sure that coupled with the right code, they will give your next project a nice clean user interface. This is a nice compact 18 volt 2.5 watt solar panel. Probably not the best efficiency out there, but for the cost of $5.50 with free shipping, definitely worth getting one. It's about 19 centimeters long and 12 centimeters high, and I plan on using this panel together with some charging circuit to recharge the batteries of my plant watering system. Right now you'll see a card in the upper part of the screen linking the video where I show you how I built my own plant watering system, so go check it out. I'm not sure if I'll stick with the 5 amp lead acid battery or if I'll switch to some 18650 cells, but either way I would like to use this panel to keep my batteries charged so they never require external power. And it should be possible because during the day I get plenty of direct sunlight, and when I get to upgrading that system with this solar panel, I'll post a video, so stay subscribed. And the last item for this episode is this Hookup repair wire spool. This one is AWG30 and it can be used for all kinds of repairs. For example, where you need to redo a small circuit trace that got interrupted or anything like that doesn't require high current pass-through. For example, I mentioned earlier for the USB module that I could solder some wires directly to the QFN pads. This kind of hookup wire is what you need for that kind of job. Link for this and all the other products will be in the description below, so do check them out. This was quite a lengthy in the mail episode with lots of interesting stuff, and there is still more stuff delayed in transit due to the recent holiday period, so don't forget to subscribe and follow me on Twitter. See you next time.